Welcome everyone. Here's kind of an introduction to the Power Lab. So I know you weren't here in class today, so this is something you're gonna be able to do at your home. I'm assuming that at your house you have some stairs. Hopefully it's more than just like 2 or 3 steps into your garage, but I'm assuming you have some stairs. If not, we can figure this out and let me know if that's not the case. But the idea is you are going to go through and you're gonna do this for your stairs at home. So you're gonna have to go through and measure the height of one stair, okay? And I would encourage you to use centimeters and then convert it to meters, divide by 100, or it's up to you. You could use inches, like how tall is this one step in inches, and then from there, Google can help you with that conversion. You need it in meters though. So measure one stair and then determine how many stairs you have. Now, if you are like, if they call them like bi-levels, where you kind of walk in and then it goes like up or down in the stair flight, I would start at the bottom, very bottom, and then go up to the front door and then go up to the upstairs. So I do both stretches. So how many total steps you have. So take however much the height of one step times the total number of steps, and that'll give you your total height that you're gonna climb when you climb your flight of stairs. There's some information up here, there's some conversion factors. I don't care what your weight is, and if you're sensitive about that, lie to me. I don't care. But I do need to know your mass. And the way you can determine your mass is you take your weight, 200 pounds, 220 pounds, 150 pounds, 100 pounds, whatever it is, and that's 1 kilogram is 2.2 pounds, so you take your weight, and if you divide by 2.2, you will get your mass in kilograms. So easy math, if you were 220 pounds and you divide by 2.2, you would have a mass of 100 kilograms, okay, along those lines. So whatever this number is, make it up, lie to me, I don't care, but you have to divide by 2.2 to get your mass. Whatever this number is the number you have to use for your calculations. So what you're ultimately trying to do is you're gonna calculate your work in, because you're gonna calculate your power, and then you're gonna make a conversion to horsepower. So I'll show you in today's in-class lesson, we talked about this yesterday or Monday or Tuesday, we talked about Matthias in terms of his stair climb. The calculation we did in class on Monday and Tuesday is identical to the one you're about to do. So the idea for this calculation is there's 2 ways we can find work in. But the way we are going to calculate work in is work in plus the work done by friction is equal to our change in mechanical energy. Okay, that's what we're going to be using. So to kind of break that down a little bit further, work in plus the work done by friction is equal to ME2 minus ME1. Now we are going to say that the amount of friction is pretty negligible, because when we're talking about friction in this situation, how much friction was holding you back from going up? So hopefully very, very little. So if we look at my wonderful picture on the board, we can kind of talk about a few things. We are gonna make some of the same assumptions that we did with Matthias, that when you start at the bottom of the stairs, your velocity is going to be 0. And I would define your height to be 0 too. It makes your life really, really easy, or easier, I should say. Okay. Then, once you get to the top of this flight of stairs, you can't go up anymore. Therefore, your V2 is also going to be 0. This H2 is what you're going to get from your number of stairs times the height of each stair. That's going to be your H2. That's going to be specific to you and what you're going to have. This is just an example of if I was 200 pounds, I would take this just like we did in chemistry and divide by 2.2 to give me my number in kilograms. And then we can go through, and then this is the equation we're going to use. Because then once we solve for work in, we can then put it into our power equation, and you will have timed the amount of how long it took you to go from the bottom to the top, and then that's going to go right there. So when we talk about this ME2 and ME1, we're talking about kinetic energy at the top. We're talking about gravitational potential energy at the top. We're talking about PEE, spring potential energy, at the top. Minus ME1, KE1, PEG1, and PEE1. A lot of this is gonna cancel out, but then once you get that, you should be able to solve for this because we already said that's gonna be negligible. And then we can go through and we can solve for power. Just to kind of tell you, your power is probably gonna be in the thousands. Okay, I'm sorry, no, take that back. Your work is probably gonna be in the thousands. The amount of power you do, it depends if you run, if you walk, but it's gonna be probably in the hundreds of watts. And then to go from watts to horsepower, you take however many this is your number, I'm just gonna call it X, this is you. If you divide that by 745.7, that will give you your horsepower. And most people are under a horsepower when they do these. If you're heavier and if you go fast because you run, you might break a horsepower, but if you're just gonna walk, you're probably in the like 0.2, 0.3, 0.4 horsepower range, somewhere in that ballpark. So again, working is in the thousands, power is gonna be in the hundreds of watts, horsepower is probably gonna be a fraction. If you have questions, let me know.